In this video I'm going to show you my workflow how to get from an EasyEDA project like this to a wonderful fitting 3D printed enclosure like this. I often design my electronics projects in EasyEDA because I think it's easy to use, and also it's very easy to export the projects, to order PCBs from JLC PCB and even have them assembled. To demonstrate the export and my workflow for creating enclosures, I put together a simple PCB with just a few components to make it easy to demonstrate. You can use the built-in 3D visualization to see how your PCB looks, and you also can export the whole PCB into an object file. Sadly, this OBJ file is not really suited to be worked with in Fusion 360. And what the problem is, I'm going to show you here quickly. So I exported this OBJ file, and even here in the file browser we can see that there are holes in the PCB. There seem to be some problems. Now let's import it into Fusion 360. In order to do that, I create a new component. Separating things into new components is anyway a good idea. That also makes it easier to hide it or even delete it later. So here comes the import of the mesh. Now we can see, okay, it doesn't look that bad. There are some weird faces on the PCB, and colors look a bit strange, but now if we measure the dimensions of this PCB, it also shows that it was imported in the wrong scale. Here it shows 196 millimeters, and the real PCB is only 50 somewhat millimeters. So this is completely unusable. If you want to build an enclosure around it, it would be in the wrong scale. So this was just for demonstration. Now let's delete the mesh import again and do it the proper way. As the first step, I always create a component for the PCB, since we will build everything around the PCB. Now let's get back to EasyEDA and export the layout into a DXF file. In Fusion 360 you can choose the import option, and I would recommend to do one sketch per layer. That makes it easier to separate the different layers from EasyEDA in Fusion 360. On the import dialog you also have to select the plane to which the sketches should be attached to. Now we can see that Fusion 360 detected the different layers that we had in EasyEDA. That's perfect. At this point I like to create a new sketch which lets me select the features from the different sketches that I need for my design. So I pick the plane again. Now I'm in the sketch mode. I name this sketch so I know what it is, and now I start selecting the features, the holes, the outline, and so on. You can also see that in this import there are a couple of problems. The mounting holes for the USB-C connector are the wrong way around. Also the outline itself is not closed, otherwise Fusion 360 would display this differently here. So these are problems that we will fix manually later. As a general rule, I select the features that will help me to get the complete picture. Probably I'm selecting too many features here. In many cases for placing components, the corners would be enough, but better safe than sorry, so I select maybe a bit more than I actually need. For this initial selection of features, I disable the projection link, which allows me to fix and change the features in my new sketch more easily. Now I disable all the other sketches, so I really just see what I decided to import. To fix the mounting holes of the USB-C connector, I use an arc which gives me quite pretty looking holes. Another problem we really need to fix is the outline, which is not closed. This would make it impossible to create the actual PCB. So here I used the same 3-point arc to close. Now we can see that the color of the PCB changed. So that's perfect. Let's finish the sketch and extrude it into the PCB. I use the same thickness that I know I will use when I order the PCB from JLC PCB. That's 1.6 millimeters. I also recommend to extrude it away from the plane where the sketches are. That makes it easier that the features are on the surface of the PCB. For every electronic part I want to visualize in Fusion 360, I create a new component that makes it easier to place them and keep them separate from each other. So for instance, the USB-C connector, the ESP32 rover, and the LiPo connector. Now we need to get 3D models for these electronic components. EasyEDA already has them for many of the parts that come from their own library, as we can see here in the 3D visualization. So now comes the trick how to export the 3D models for those components. You go into the inspect mode in your browser. That's available for sure in Chrome and Firefox. And here we can see what goes on behind the scenes. We change to the network tab in the inspect mode, and on the sidebar we click on the 3D model. Now this forced EasyEDA to load the 3D model. It's there in a list with a cryptic name. If we click on it and select Open tab from the menu, we download it and we can give it a name and also a type, which is OBJ in this case. And now we can see the file browser can already visualize it, so we have the right component. Now let's do that for every of the other components as well. In Fusion 360 we need to import these OBJ files as meshes. Some of them will have some problems which we will need to fix. Fusion 360 will show us this situation with a exclamation mark and a sign beside the object in the object browser to the side. So here we can see that. We can work with meshes in the mesh workspace. Under prepare, you can choose the repair option, which will fix some problems like holes, wrong directions of faces, and so on. Now we have a working mesh, but I prefer to convert them into something that is easier to work with, that you can do from the modify menu. I also like to move the component a bit into the right direction and more or less into the right spot. Not perfectly yet, because we will use the align feature later to get it into the perfect position. So it should be more or less on top of the place where it will be later. Also make sure that you select the capture option, otherwise you might lose that position later. Now let's do that fast forward for the other two components as well. I usually only do that for the components I really need to interact with the enclosure. So you don't have to do that for every resistor or capacitor, just the things that somehow have an impact on how you design your enclosure. Okay, great. Now we have the components imported and more or less in place. Let's now move them in the correct position. So let's start with the USB-C connector. By using the Align tool from the Solid menu under Modify, we can line up features from the electronic components with the sketches we imported earlier. So for the USB-C connector, this mounting plug is a very good and easy feature. Also, don't forget to use the capture position. We selected the one feature on the component, and now we need to find the appropriate spot on the PCB or on the sketch. This would be the matching hole. We can either use the one on top or bottom, but neither of them is perfect, so I choose the one on top. Now you can see another problem that might happen from time to time. Our component is upside down and also otherwise not properly aligned, so we use the flip and angle buttons to bring it into the perfect position. So now this looks good. The component is aligned in two axes. Now we need to align it in the height as well to bring it down onto the PCB. So we select a face that we know should be lying or be in contact directly with the PCB, and we select the mating face of the PCB, and the component moves down. Again, don't forget to capture position. Now looking from front, or actually back in this case, we can see that the USB-C connector is perfectly aligned to the PCB. Now we'll do that for the other components as well. Here we use slightly different features. We have to see what is easiest. In the case of the ESP32 rover, we will use the edge of the module close to the PCB antenna. We first need to enable the sketch again because we turned it off or disabled it before, otherwise we cannot match it. So we select the corner of the PCB module and the sketch feature that should be matched, and in this case it just worked perfectly. No second step necessary here. And now let's do that again as well for the JST connector. It's always a bit of looking at the feature which might be represented best. So here I decided to use this inward corner. It might be matching with the one from the footprint that we imported. Now let's find it in the sketch. It's hard to see here, it's in light blue on the gray background, but this seems to work quite well. Maybe we'd have to adjust this manually a bit more if it was important, but the JST connector is more important for the height, so I'm leaving it as it is. Now we have all the components placed on the PCB that are relevant for creating the enclosure. This is the important part I wanted to show you, but to go one step further and maybe also show that step, let's create a simple enclosure. I want to do an enclosure that consists of two parts, a bottom part and a top part. So let's start with the bottom part. We will start by creating a sketch based on the top of the PCB plane. Let's remove the components since they're a bit distracting here. And now we can choose the PCB plane as a base for our enclosure. In this case, I select the projection link because if I change something on the PCB, I also want this to be represented in the enclosure as well, unlike before when I did not select it. Now since I want the circle around enclosure, I close this outline of the PCB, which will allow me to create an outline um, from which I can then build or extrude the enclosure. This measurements or the offset value, it's always a bit trying out how much tolerance you need. So I'm going here with 1.5 millimeters, and this is the outermost parameter of the enclosure. Now I will extrude it. I probably will need some space for a battery for this device, but I can also change this later again if I see that I need more space. Now I have a solid body, but I want this to be empty inside, or a shell. So I select the body, I go to modify, and I select the shell feature. Now I can tell how thick the walls should be. I go with 1 or 1.2 millimeters. Now I select the PCB again to see how much space I will have between the PCB and the wall. Or maybe 1 millimeter and a bit more gap is better for tolerance. So that fast, and we already have the bottom part. Now let's create another component for the top part. We will start off from the face or the plane of the already created enclosure part, the bottom part, since the two should be fit together later. Then we'll also extrude, or actually first create a sketch and then extrude the top part from this sketch. Now here, as I mentioned before, the JST connector for the battery is the relevant part for the height, since it is the highest part, or the highest component. But be sure, let's enable all of them. So we'll extrude that plane towards the components, and we'll select only to one side, but then to object. So we can select a top plane of the JST connector. This is a bit hard to know which plane is actually selected, but let's just pick one. And now the top enclosure is extruded exactly to the height of the JST connector, but we want to have a bit on top of that, so we add 1.5 millimeters. That should give us enough space later. Now this is again a solid body, so we'll create a shell from the solid body, and we might have to disable the other components so we can easily work with the top part. So we choose the same wall thickness of 1 millimeter. Now let's again select all the parts so we can do a check that everything fits together. We can also use the section analysis tool to see how it looks inside of the enclosure. Let's select the plane from which this section analysis could be created. We can move the plane where this crosscut is created, and we can see here that there is enough space above the JST connector to fit into the enclosure. And as next steps, we'd have to create the bosses for the screws and maybe some other features where we interact with the outside. So for instance, a USB connector would have to be cut through the enclosure. I hope you liked this tutorial about how to import PCB information from EasyEDA into Fusion 360 to model enclosures. In this video you see here, I show how I did that for the enclosure that I showed initially in the video. If you like this tutorial, please let me know in the comments and subscribe to this channel. Thank you very much for watching. Bye.